nothing but it's a severe acute respiratory syndrome coronavirus. So the severity, it actually based on the immunity of the body, like it varies. Okay, and also the age, with respect to age, it varies, and many at the early stages, like. I'll just come to that. In the early stages, it was actually very difficult to identify whether it is a normal flu or a COVID-19. So in the Middle East, in the Middle East, the respiratory syndrome coronavirus is actually named as MERS-CoV. And influenza A viruses are major pathogens which primarily target the human respiratory system. So this affecting the respiratory system, it actually it varies. The level of impact, again, that is also varies and varying one. So diseases associated with their infections vary from mild respiratory illness to acute pneumonia and even respiratory failure. So these are the different stages, 3 stages we have seen. Okay. And since 1918, these influenza A viruses have caused 4 pandemics. We were actually only, we met with this COVID-19 phase. So we could able to feel only that particular scenario. But the first one, it was actually, it's a severe pandemic one. And it was actually called Spanish influenza. And that occurred in 1918. And the next one, so in that one itself, 500 million people were infected and 50 million people expired. And that's because of H1N1 influenza A virus. Once again, it's not moving. Visible? The screen is visible, sir?
Visible.
Yes, madam, it is visible.
Yeah. It is visible, madam.
Yeah, okay. So that is the first phase. And the second pandemic, it is actually known as the Asian influenza, which occurred in 1957. And that was caused by H2N2 IAV strain, and which resulted approximately in 1.1 million deaths, which is again worldwide. The third pandemic was Hong Kong flu, which occurred in 1968. And this is because of the virus H3N2 strain. And again, that one actually resulted in approximately 1 million deaths worldwide. The fourth one, which is actually caused by influenza A, H1N1 virus. Again, it is actually novel influenza A virus, which resulted in approximately on 1,51,700 to 5,75,400 deaths. Again, it is actually worldwide during 2019-2010. So this this influenza A virus, which is actually known to the world already, and it continued to spread as a seasonal flu virus from September 2019 to February 2020. This again, it caused like 34 million flu illnesses and 20,000 deaths. In November 2002. Before that influenza A pandemic, an epidemic caused, that is not actually pandemic, that's an epidemic caused by the beta coronavirus, again SARS-CoV, and which is known as SARS, that is severe acute respiratory syndrome, which started in South China and spread over to 29 countries. The SARS outbreak, which again caused approximately 8,000 infection and 774 deaths. In 2012, Saudi Arabia reported the first case of Middle East respiratory syndrome, MERS, and this particular version of beta coronavirus, it spread to 27 countries. Again, there were 2,519 infections and 866 deaths in January 2020. In 2019, December 2019, cases of new coronavirus disease 2019, that is COVID-19, caused by the new beta virus of SARS-CoV-2, which was reported first in Wuhan, China. That one we know very well. Okay, so that outbreak rapidly spread worldwide, and it has infected more than 60 crores, 33 lakhs, 28,548 individuals globally, and resulted in more than 65 lakhs, 1,469 deaths. In India, 4 crores 75 lakhs 22,777 infected cases and 5 lakhs 28,273 death cases as on 19 September 2022. Again, in Tamil Nadu, 35.8 lakh infected cases and 38,040 death cases. So these are some of the statistics. And we are also one of the victims of this particular SARS-CoV-2. So there are various pandemic situations which occurred in globally in different stages or different periods. Now this is about the statistics about coronavirus. Okay, how actually the automated systems, or you can say that the learning models helpful in this particular COVID era. So health informatics, again, just it's nothing but it connects everyone, all the people we know very well. That is during this pandemic period, that is web was the one which was connecting everyone. Here, health informatics, it plays a very important role. It connects people, technology, and data to better improve healthcare outcomes and safety by typically, we know very well that is telemedicine and so on. Everything, it was actually popular only during that time. So, which is actually helpful for the safety of the people by supporting operational and technological advancements globally. So some of the few examples are that is patient portals, electronic medical records, telehealth systems, healthcare apps, and a variety of data reporting tools. And here, like, what is the need for health informatics in this particular era? So, this health informatics drives operational efficiencies that enable streamlined comprehensive care and the protection of patient data. And this covers health data collection, storage, extraction, manipulation, reporting, and communication through technologies like wearables, apps, telehealth. And this again includes designing the system, configuration and management of health information and clinical support system. It plays a very major role in analyzing, preventing, diagnosing COVID-19 in different ways. And again, the need for automated system, that is again that actually it has for this particular spread of COVID-19, it plays a tremendous burden on public health, and that is public and as well as private testing laboratories. For every positive case, thousands of people are screened. Maybe there may be, but all are not positive cases. That is, which is nothing but unnecessary one. And people are that is they were having a fear always that whether they are having, so there'll be just many times they used to do tests in the early stages. So due to this rapid increase in the number of samples that need to be processed in very short times, this highlights the urgent or the need to have a widespread and reliable detection testings in labs all over the world. It happened. So there are significant benefits which actually reduces the risk of cross-contamination, reducing errors caused by manual intervention, reducing exposure time of laboratory staff to potentially harmful reagents and pathogens. So because they are also exposed to that. And all of this accomplished with the added benefit of increasing sample throughput. The automated system is highly needed to overcome these problems and to work towards the large screening of COVID-19 viruses. The role of learning techniques. COVID-19 has become a global pandemic, which even the World Health Organization declared in the case that is in February 2020, it's a pandemic stage. And there are that is artificial intelligence based techniques like machine learning, deep learning techniques. Those play an essential role in determining that is the patients populations who have COVID-19 in various aspects. So these learning techniques allows the user to imitate that is the it will be just working for the working as an artificial intellect, as well as to absorb massive amounts of data to detect trends and observations quickly. And these are learning algorithms construct networks across layers that build an artificial neural network intelligent enough to understand and making rational decisions concerning COVID-19 diagnosis. Now, we'll just move on to, that is a machine learning approaches available, and after that we'll just move on to the deep learning approaches. So this machine learning, which focuses on application that will learn from experience and improve their decision making or the predictive accuracy over time. And especially in machine learning, algorithms are trained to find patterns and features in massive amounts of data in order to make decisions and predictions based on new data. So that will help us to just find new predictions. And it is proven that also successful that extracting the different features and information from the medical images, which will help or support accurate diagnosis of the data. So find the more accurate the decisions and the predictions are, which will become as like it will be. So we'll be getting when we have more and more of data that is for training, and that is which will be helpful for processing. With that, we can find the based on the trained data, we'll be finding the patterns which will be helpful for accurate decisions as well as predictions. So we have actually many types of machine learning models. Okay, so this machine learning models allows the systems to make decisions autonomously without any external support. Both machine learning and deep learning all are like autonomous systems. They need not have any external support. And these decisions made when the machine is able to learn from the data and understand the underlying patterns that are contained within it. So through some pattern matching and further analysis, they return the outcome, which can be helpful for classification as well as for prediction. So we have actually just going to see three different or important machine learning approaches. One is supervised, and the next one is unsupervised, and third one is reinforcement learning. So first one, supervised learning, it's a most popular paradigm for performing machine learning operations. It is widely used for helpful for data where there is actually precise mapping between the input and output data. So now here the data set, if I say like it is actually labeled, meaning that the algorithm identifies the features explicitly and carries out predictions or classifications accordingly. That is with respect to a particular labeled data. So as the training period progresses, the algorithm is able to identify the relationship between the two variables so that we can predict a new outcome. So as a result of this supervised learning algorithm, so these are actually task oriented. So we have actually we can learn more properly so that from the data so that it can undertake the task and yield as the output more accurately. So for example, I have actually a set of data grapes. So then the annotations which we use are, these are grapes. So this is a supervised algorithm. The model will be just working only for the input given, and it will be just giving the prediction is it's grapes. The next one is types of supervised learning algorithms. Some of the algorithms that come that will be helpful for that is or specialized supervised learning algorithms are linear regression, random forest, gradient boosting, SVM, support vector machine, and logistic regression. The next one is unsupervised learning algorithm. So here the data is explicitly labeled into different classes. So there are no labels. Okay, it is actually explicit. The model is able to learn from the data by finding implicit patterns. Okay, so these unsupervised learning algorithms identify the data based on the density, structure, and segments which are actually similar, as well as the features which are similar. Okay, so this is otherwise also called as Hebbian learning algorithm. Okay, here actually the cluster analysis is one method which is actually widely used. Here, see this one, like here we have actually different types of fruits. So that's the input given. So here there is actually labeling is not there. So this the model will be working in such a way that it will be just classified appropriately. That is, the each classification is completely unique. And the types of unsupervised models available are like it is actually the clustering model is the k-means, DB scan, and hierarchical clustering. And the next one is anomaly detection, autoencoders, deep belief networks, and principal component analysis. The third category one is in the case of machine learning is reinforcement learning. This will be just coming under as a part of AI, and this allows machines to interact with their dynamic environment in order to reach their goals. So here, the machines or we can say that the software agents are able to evaluate the ideal behavior in a specific context. Again, this particular reinforcement learning, so there is no answer key which is actually provided to the agent when we have actually when we are interested in executing a particular job, or so we'll not be having a particular key. So the agent will not be having that, and but actually we can expect the output. So there is no training data set. Also, it learns from its own experiences. So like it's like sometimes like we can say that that is I just forgot the name. Okay, so like based on the experience, learning will be made. So this is one example. Now here actually the environment is that we have actually a question answers, and we have actually set of questions and answers. The agents will be working so that it will be just aggregating the answers, and it will be just formulating the questions. And the user, whenever actually he's working, like he'll be just trying to find out, or he'll be just working for the he'll be giving the answers like whenever the question arises, like again that is nothing but it is every time it will be just the agent will be just it will be working on its own. And the next one is how this machine learning algorithm works. So we'll be just finding out, first of all, a training data set, okay, selecting and preparing a training data set machine that is which will be for a particular application, and choose an algorithm to run on the training data set. And so the machine learning algorithms which are used with the labeled data, or that is there are and the other one is unlabeled data. For labeled data, regression algorithms, decision trees, instance-based algorithms are there, and for the unlabeled data, clustering algorithm, association algorithms, neural networks are helpful. So, so, so we'll be just creating a model that is with the effects of training the algorithm, and so we'll be just effectively using it so that an improved model is identified. And what is actually deep neural networks? The next one is we are moving on to deep neural networks. So this is a function, or you can say that deep learning model that imitates the working of a human brain in processing the data and creating the pattern. So it is some cases it is called as DNL. And in some cases, or otherwise also it is called a DNN. So mostly it is actually otherwise called as deep learning model. So it uses both structured and unstructured data for training. So we have actually various studies which conducted on COVID-19 with the different deep learning architectures. So in a number of these studies, their diagnosis rate was compared with the detection of COVID-19. So with the help of these architecture, one of the main features of the deep neural networks is actually its efficacy with respect to the employed architecture. So this will be demonstrating an extraordinary ability to perform a variety of functions on different types of data. So this one actually, it's a simple CNN model, like how actually it is. I just cropped this from a particular in one paper. Okay, so what are the different models available, and how it is, how many percentage it is actually used. So that one actually it is there. For example, GoogleNet, it is actually 5.4%, and CNN models, it is 8.1, ResNet 18.9. Okay, so let's like these are the different models which is actually available, and so the studies on the various deep learning techniques that shows that actually there is a need for detection, diagnosis, classification, prediction, and prognosis of COVID-19. So the domestic data sets, like including CT and CT scan images and X-ray images, or the public data sets, have been employed in some studies in which training or testing data sets were used to train and validate the methods. The criteria for measuring the efficiency of methods used in community studies include, that is, these are the metrics used: sensitivity, specificity, and accuracy. Mostly we'll be using only accuracy, and area under curve also in some cases we'll be using finding the to determine the efficiency of the system. So that actually COVID-19 is perfectly detected, diagnosed. And next one is we move on to the deep transfer learning techniques, so which will be helpful for getting better efficacy. Okay. So that is actually transfer learning techniques is a technique which focuses on storing knowledge gained while solving one problem and applying it to different but related problem. So we'll just get a solution for one problem. So that knowledge will apply to another problem. So the problem may be related to the same problem. So that actually we'll be getting better results. So this is called a pre-trained model. So this diagram will be helpful for that. Okay, so this is suppose take an example of this is actually a problem one or application one, task one. So we apply that and model is adopted. We get predictions. Okay, this knowledge is transferred to the other for the problem of similar type. Okay, that means for the different data set, same model is applied, and but this knowledge is applied, so we'll be getting new identification. Okay, suppose like a knowledge gained while learning to recognize cars could be applied for trucking also, for trucks also. So we can just the knowledge which we have obtained, or the knowledge or a learning model which we applied for identifying or recognizing cars can be same, can be because car and truck will be of it's a vehicle type. Okay, this is the same problem. So that knowledge can be adopted here. The pre-trained models which are used for image segmentation. So some of the commonly used pre-trained models, which is actually helpful for CT scan images in the case of in COVID-19 diagnosis, are MARC, RCNN, YOLO, MobileNet, DeepLab V3 Plus, UNet. So first one is Mark or CNN. It's a flexible framework developed for the purpose of object instance segmentation. So this particular pre-trained model is an implementation of Mark or CNN technique on Python and Keras. It generates bounding boxes and segmentation masks for each instance of an object in a given image. So this this particular pre-trained model, actually there are different models used, and different types of data sets are used, and the accuracy also to a particular model there are different data sets actually obtained different accuracy levels. Marks are CNN, like the 534 COVID-19 positive cases were used, and 134 COVID-19 cases were used. So with that, 96.98% of accuracy obtained. So the next one is like, I just have listed so many. So here again, next one is COVID XNet. Again, that is actually a model which was tested with the 25 COVID-19 positive cases and 90% accuracy obtained. And VGG19, 53 COVID-19 positive cases and 5526 COVID-19 negative cases were used for this particular pre-trained model. And 93.48, that was the accuracy obtained. YOLO, it's nothing but you only look once. So that's again a new technique which was actually helpful for real-time object detection system. So this particular object detection framework, it actually contains that particular repository contains its actually implementations of different versions of YOLO. And so this particular one actually where like face mask, it is actually helpful for face mask detection, red blood cell detection. And so where actually this is applied, suppose take an example, a group of people are entering a multiplex or mall and all. So there actually whether the person is wearing appropriately the face mask. So like that, actually for that particular detection, this particular model can be helpful. And So we can combine this YOLO with other learning models so that actually the infected area in a particular chest CT can be detected. So this was tested for 19 patients. Next one is a mobile net. Actually, it's an architecture designed for mobile devices, and it has been built by Google. And so we have actually this particular pre-trained model. It the database contains millions of images belonging to more than 20,000 classes. Okay, so it is actually like the facial attributes, landmark recognition, so these are some of the applications. That is object detection means these are some of the cases. Now, now this particular mobile net actually it obtained, this is the training loss and this is the validation law. The accuracy, we'll see the only the accuracy obtained. For mobile net, accuracy obtained is 98.03 obtained, and validation accuracy is 96.88%. Okay, so apart from that, we have VGG A16, DenseNet, ResNet 50. And the next one is a semantic image segmentation. So this is actually assigning a semantic label to every single pixel in an image. So this is actually a Google's latest semantic image segmentation model. It was originally created using TensorFlow, and it has been implemented using Keras. So again, this particular thing on DeepLab V3 Plus is actually the technique uses exception 65, MobileNet V2, ResNet 101. So the range of accuracy, it is actually varying from 90 to 96. Precision, it varies from 88 to 91 and 96 to 97. Specificity. So for example, next one is that is UNet. Actually, it is helpful. It is used for robot surgery segmentation. So this particular model, it attempts to address the problem of image segmentation of surgical instruments in a robot assisted surgery scenario. So there are actually two parts which can be the problem can be classified: binary segmentation and multi-class segmentation. In the case of binary segmentation, every pixel is considered as an image and it is labeled as an instrument or background. In the multi-class one, different instruments or different parts of an instrument are distinguished from the background. So this particular pre-trained model, it is based on unit network architecture, and like it is actually the improved versions of this one. Helpful. It is actually named LinkNet and TernosNet. So this particular UNet model, it's a convolutional neural network, which is fast and precise segmentation of images. One of the best model actually is nothing but for biomedical image segmentation is 3D UNet and 3D CUNet. So these are some of the values obtained or the results obtained. So the next one is the pre-trained models used for image classifications, which are already available. AlexNet, VGG, GoogleNet, ResNext, SqueezeNet, ResNet, DenseNet, ShuffleNet V2, MobileNet V2. So these are the years with which actually it was actually entered or developed. So that also it's mentioned here. So next one is AlexNet. AlexNet is actually one of the popular variants of CNN, and it is used for deep learning frameworks. So here, the complete network design of the AlexNet, it contains 8 layers. The first 5 were convolution layers, some of them followed by max pooling layer, and the last 3 were fully connected layers. So first 5, it is convolutional layers, and last one is fully connected layers. So next, the middle one is max pooling layer. So it's actually we can say that this AlexNet uses a non-saturating ReLU activation function, and it can also be we can also conclude that AlexNet model has a very good performance when it is used as a transfer learning framework. So while training a classifier in which a simple neural network model has been defined for multi-class image segmentation, image classification. And the next one is VPG. Again, this is actually a convolutional neural network with specific architectures. Okay, and this was actually developed by a group of people from University of Oxford. And this particular VGG group, it participated in an annual computer vision competition that is actually famous ILSVR3RC. So actually this ILSVRC, it is actually a very, very famous competition. And some of the models are named with this particular competition name itself. And this particular group, they have submitted their model, and they challenged that, and because of that actually they could able to achieve a new model VGG. And VGG 16 is nothing but it has actually 16 layers, and 19 it has 19 layers. And this particular deep learning model or deep convolutional neural network use a transfer learning framework where it uses the weights of pre-trained image net. So the pre-trained VGG 16 model is nothing but it's actually a convolutional neural network trained on 1.2 million images to classify 100 different categories. So here actually we can just obtain the different types of, like, after that actually there are so many variants of this one, and we can get different classifications. Google Net is actually again a convolutional neural network which uses 22 layers of deep neural network. And so this actually we can have again this also uses a transfer learning approach. And the most common approach is to use networks pre-trained on the ImageNet data sets. So there's a disturbance. Sir? 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 So, okay. So with the use of this transfer learning technique, we can use Google Net network like it is actually, which will be trained on ImageNet without implementing or training the network like by ourselves. And the next one is ResNext. Again, this is a network model for based on transfer learning technique, and it has actually too few samples, and the model is pre-trained on the public image net database, and it's transferred to the task of human motion recognition based on the multi-radar. And this particular one, it actually forms a building block that aggregates a set of transformations with the same topology. Compared to ResNet, it exposes a new dimension cardinality and an essential factor in addition to the dimensions of depth and width. So this model was trained on billions and billions of images using thousands of distinct hashtags as labels, which exhibit excellent transfer learning performance. SqueezeNet, this is again another CNN architecture, which has actually 50 times less parameters than AlexNet, but actually it maintains good accuracy. And we can just see that it has showcased the architecture of the model along with the implementation of the ImageNet datasets and the compression techniques. So this, with the help of this deep compression techniques, we are able to fit this model on devices such as FPGAs, where actually we'll be having actually only an on-chip memory. And then ResNet, this was proposed by a Microsoft research team, and this particular model has actually it's a neural network model which applies identity mapping. This actually it has actually input to some layer which is passed directly or as a shortcut to some other layer. So consider like considering these things, like we have actually now see we have directly it can be moved on to the last one, or it can act as a shortcut like X to last one. So we have actually the ReLU function. Okay, so these are it uses actually this particular network uses a 34 layers. And the next one is DenseNet, and it's a logical extension of the ResNet. We can some cases it is also called as ResNet itself. It connects each layer to every other layer in the feed-forward fashion. Okay. So the traditional convolutional networks with the L layers have L connections, one between each layer and its subsequent layer. Our network has L into L plus 1 by 2 direct connections. And it has been built as a model with actually approximately 98% of accuracy. So it requires that is it only needs a fewer parameters. To train the model, it requires only few parameters. It doesn't require volumes of data. And the dynamic feature propagation takes care of the seamless flow of information. ShuffleNet, it is nothing but it's another variant of Shuffle, and it is composed of group convolutions and channel shuffles. Group convolution is nothing but it's actually considering only a portion of the input channels, and a group convolution with the three. Let us take three groups. Each will be taking like three different input channels. And the next one is like how actually the application, like some of the applications of deep learning approaches in COVID-19 disease management. So the AI approaches, like specifically talking with respect to a deep learning model, is being successfully used in the identification of disease clusters, monitoring of cases, prediction of future outbreaks, mortality risk, and diagnosis of COVID-19. Disease management by resource allocation, facilitating training, record maintenance, and pattern recognition for just studying the disease trend as on data. So there are several applications of AI. Deep learning in prediction and tracking, deep learning in contact tracing, deep learning in monitoring of COVID-19 cases, deep learning like where actually which will be helpful for medical practitioners and healthcare staff. That is supporting one for medical practitioners, and protein structure prediction, the deep learning model for development of therapeutics and vaccines, deep learning model for curbing spread of misinformation and genomics, and deep learning model for um, early diagnosis of COVID-19. So some of the cases like medical imaging, diseases tracking, protein structure prediction, drugs discovery, virus severity and infectivity. So these are the different classes where actually the deep learning models are used supporting for that is COVID-19 cases. So the first one, the deep learning model in prediction and tracking. So it will be just helpful for forecasting the spread of virus and developing early warning systems by extracting information from a social media platforms, calls, and news sites. It provides useful information about the vulnerable regions and for prediction of morbidity and mortality. And blue dot, like that's which has identified a cluster of pneumonia cases and predicted the outbreak of geographical location of COVID-19 outbreak based on the available data using machine learning. So especially in this COVID pneumonia cases, detection of COVID pneumonia cases, it's very, very difficult in the early stages, because in 2020 and 20, even say that early 2021, it was difficult to identify whether it is actually COVID or not, because like at that time it was actually the quarantine period was 15 days or 14 days. Okay, so after that, if the people are coming for diagnosis, so that time it was actually concluding as negative cases. I hope you'll all accept. After 15 days, it will be just always telling negative. First, after 5 days itself, it will be just concluded as negative. But the people might have been affected by COVID-19, and it would have just entered, or it would have just gone to that stage, that is actually they'll be having actually complete lung infection. And so at the early stage, that is to 2020 and early 2021, it was concluded as a normal pneumonia. There was no actually exclusively the name of COVID pneumonia was not at all identified, even later 2020. Only after, that is 2021, it was actually classified as COVID pneumonia and normal pneumonia. Okay, because normal pneumonia, they could able to just sense and they could able to just medicate the patient. But COVID pneumonia, it was very difficult to identify because it will be just concluded as pneumonia patient. But the infection level was very, very high. Because of that, the death rate was very, very high. Okay, so the health map, which was actually collecting publicly available data from the COVID-19, that is on COVID-19, and it was actually effectively used for tracking the spread of the disease. So the role of AI in identification and forecasting of COVID-19 outbreaks by employing the multimodal data, which was actually emphasized. So see this one, COVID-19 cases were actually data was collected and it was pre-processed. So the clinical data, textual data, genetic data, which was again different for different problems, different types of data it can be collected. And the models like machine learning model, AI models or deep learning models, which was actually applied. And we have actually detection, prediction, diagnosis and prognosis models. As a result of that, we'll be getting the final result, either it is for prognosis or for prediction or for diagnosis or for detection. The next one is contract tracing. So mobile health applications where actually smart devices like watches, mobile phones, cameras, and range of wearable devices were employed for diagnosing and contract tracing, and also for efficient monitoring in COVID-19. So applications like A14 COVID-19, which was which was nothing but audio recording samples, like a cough of the person was actually captured, and it was used in telemedicine. The next one is contact tracing. That's the same thing which I told now. Contact tracing, like the quarantine, the first symptoms, like upon first symptom, then the sample were tested and the patients were isolated. And the contacts of that particular person was actually, it will be traced and quarantining the contacts. So this is actually an exclusively a unique problem. I think that ROK say the, like ROK say the application. Like application is the same, but here the model which we have adopted is actually deep learning, because that is really successful because we use voluminous data for training, and because of that we could able to easily identify. And next one is for monitoring of COVID-19 cases. So monitoring patients in clinical settings and for prediction of course of treatment. So based on that is data retrieved from the vital statistics and clinical parameters. So this will be, that is this particular model, DL model, will be providing a clinical information for resource allocation and for decision making by considering the prioritized data and for the, like whether actually the person needs ventilators or respiratory support systems or oxygen mask, or the person needs ICU care. So these things will be, that is resources will be accordingly allocated. And the next one is actually predicting the chances of recovery or mortality in COVID-19. And this is actually a daily update, how far it is actually helpful for the patients, and storage and trend analysis and charting the course of treatment of a particular patient. So this is actually a severity prediction model. That is the data set, the lung data set, it is actually extracted. And the other one is clinical features are extracted. So we have actually CNN models, which is actually at various levels it is applied. And here image-based severity prediction and clinical data-based severity, both are combined. The combined severity prediction model is obtained. And this is actually severity prediction. Next one is a progression detection. So this based on the clinical features, the survival forest is obtained, and with that actually progression prediction model is identified, detected. Okay, and the next one is we'll be just getting the severity scores, and that is actually again combined, and a combined progression model is obtained. So once again, this is another model where actually from the image data, the survival forest is detected, and that is actually again the progression model of that particular survival forest is evaluated. That is combined again here. And the deep learning model that is actually helpful in reducing the burden of from the medical practitioner for the medical practitioner and for the healthcare staff. So it's a triaging system which will be helpful in reducing the work burden of the medical staff. Whether also they many people also many health workers actually they suffered a lot. So again, that is nothing but the care for that particular person, like a system was developed. That is actually AI-based triage models. So which actually creates an automated process supporting for the medical staff. So it will just determine the mode of treatment and care by analyzing the clinical data using pattern recognition approaches. So the digitization of patient reports and also by offering solutions which will minimize the contact with the other patients as well as for the health workers. So that was supporting. And so this particular model, which was actually helpful for classification of the patients based on the severity of the symptoms and the genetic disposition and clinical reports in different categories like mild, moderate, and severe, so that different approaches can be adopted for handling the patients in the most effective manner. This particular DL model is actually in telemedicine can also be used to eliminate the need for frequent and unnecessary hospital visits by distant monitoring of cases and recording of patients' data in asymptomatic cases as well as in patients with mild symptoms, so which will be just reducing. And the other cases are like the medical chatbots, which was used for consultations and which will be reducing the physical crowding of hospitals as well as spread of infection, and which will prevent weighing down the efficient operation of clinical care services. The chatbots like Clara, that was actually providing, it will be providing a needed information that will be supporting for the patients in that is in remote cases. The prognostic prediction algorithm, which was actually predicting the mortality risk of the patients, which was using the machine learning models, that is using the extracted features derived from the data from other patients as a training data sets. This particular approach was used to predict the possibility of developing acute respiratory distress syndrome. And there are several robots and anthropomorphic robots like which was actually based on AI techniques were used for the delivery of essential services and routine tasks like cleaning, disinfecting, and monitoring of hospital settings. So this is this particular one is which was actually where actually medical data sets actually, which was helpful for diagnosis and logistics, rehabilitation, networking, communication, care, and treatment and services. So these are the potential applications where the techniques of AI can be adopted. So diagnosis, a few examples are like the challenges are like increasing medical complexity and increasing diversity of diseases. And the factors of COVID-19 are like further supply of the regular cases, need of short reaction time, and AI solutions, advanced support decision-making tools, and care systems the challenges are increasing chronic diseases and increasing number of older and frailer multimorbid patients, and that there is a need for contactless medical care. And the AI solutions for that one is actually pathways modeling, automated simulation and prognosis, and robots. And the logistics are in the challenges are increasing economical pressure, shortage of skilled medical staff. So these are the situations which we have crossed in the last 2 years. And we need actually a need of networking and rapid transmission of information. And we also we want a sophisticated automated planning of our resources and autonomous systems for knowledge and information management. So these different cases of tools and techniques for diagnosis, caring, logistics, we have seen at all stages. And this is actually for a learning model used for protein structure prediction. So the particular deep learning model will be helpful for predicting the structure of the important proteins, crucial for virus entry and replication, and provide useful insight which can actually give a way for drug development in a very short time, because that was actually necessary at that time. And the algorithm, which is actually a model based on Google DeepMind, employed deep residual networks. And that is actually again called ResNets for predicting protein structures. Okay, for that is in the domain of SARS-CoV-2. And the deep trust array program based on the customized deep CNN model was used to derive protein complex structure of SARS-CoV-2 from that is cryo-electron microscopy density maps. So this is another model. Let me just skip this one. Deep learning, which is actually for therapists, therapeutics. So which can this deep learning model can boost and complement traditional technologies by reducing the time required in bringing a drug from bench to bed. So this PD model, it actually uses, it was helpful for virtual screening, employed virtual screening and validation process by a huge margin. So it can also accelerate the pace by deriving useful data for drug repurposing or for drug repositioning by screening properties of already approved and validated drugs based on molecular descriptors and properties. Okay, so a benevolent AI used deep learning methods to accelerate its drug discovery program. Okay, for in the COVID-19 cases, actually it was helpful. And virtual screening and supervised learning to identify potential drugs against COVID-19. And the next one is actually network-based system where actually pharmaceutical methodology for finding potential drugs for SARS-CoV-2 from the already existing catalog of drug molecules and drug combination. So already, which that means the already existing drug molecules and drug combinations for COVID-19 or SARS-CoV-2 was employed for finding out new medicines or new drugs. So there are several models of DL which was actually helpful. And we have actually many machine learning models and deep learning models which was used for exploiting the drug discovery process. So this is one model like where actually COVID-19 data sets were actually applied and data were collected. And so we have actually classified epidemiological data, clinical data, and genetic data. So we just grouped that, and with the data management and processing models, again, AI-based model, machine learning model, under that a deep learning model. So the new models were applied for these data sets, and prevention method, therapeutics method, and hospital operation methods and diagnosis systems were developed. So deep learning in development of vaccines. So in the case of that is in the pandemic era, so for vaccine preparation and maintenance also, this was actually helpful. So we have actually the discovery model which can accelerate the power of AI, so that actually new vaccines were developed. The predicted vaccines were applied for different candidates for COVID-19 using Vaccine Reverse Vaccinology machine learning platform, which was relied on supervised classification models. So deep learning model in curbing spread of misinformation, that was really helpful due to the that is voluminous information. This pandemic has turned into that is infodemic. Infodemic means it is nothing but again the information was just or I can say that it was actually massive data was actually every day we got different information. So that is actually infodemic. That is the crowd, the data crowd, or that is misinformation, or I can say that misleading information was communicated. That is at different ends. So understanding knowledge, awareness, and practices toward COVID-19, and by tapping the information from social media like platforms like Twitter, Facebook, Insta, which was helpful in devising the strategy, a new strategy to assemble and disseminate timely and correct information for mitigating the impact of COVID-19. Okay, so deep learning techniques, which was helpful to identify trends and sentiment analysis and provide information regarding the whether it's a original information or it's a false information, and which was actually also helpful in curtailing the rumors as well as the misinformation. Again, deep learning models, which was actually applied for presenting a clear picture of the recovery states, accessibility and availability to healthcare, and identification of the gaps. So the the diagnosis, treatment, and spectrum of symptoms and therapeutic outcomes, it is actually highly dynamic in nature, as well as like situation to situation, it was varying one. So this particular deep learning models, which was helpful the clinicians in real world scenario, and it was also helping the public in overcoming the fear and panic. So the misinformation, again, it is actually varying one: false information, rumors, spam, fake news, disinformation. So deep learning in genomics. So there are fast and accurate classification methods available for SARS-CoV-2 genomes by applying machine learning on that is identified genomic signatures. So, and ontology-based prediction models were also like just developed or evaluated, um, so that actually the COVID-19 or the SARS-CoV virus treatment is carried out appropriately. So the genomics, like a deep DL in genomics, actually we have different biochemical data sets. The tissue data sets were actually taken, and deep learning algorithms were applied, and the annotation of the human genome and prediction of the diseases associated with the different mutations were extracted, and that is which was helpful for acceleration of drug discovery and disease diagnosis respectively. So liquid biopsy decomposition technique, it's a decomposition model which was helpful in early cancer detection. So again, how actually this deep learning model is helpful in early diagnosis of COVID-19. So the different cases of that is RT-PCR tests and chest X-ray and the CT scans, everywhere actually these AI techniques are adopted, deep learning models are adopted, and it is actually helpful for detecting different cases and differentiating COVID-19 and from the community-acquired pneumonia based on the visual 2D and the 3D features extracted from the volumetric chest CT scan. So because that CT scan, it's nothing but image data set that was collected, and in that actually the 2D as well as 3D features were extracted, and it is segregated and it is classified. So based on the classified, sorry, the symptoms of COVID pneumonia, or whether it is a normal pneumonia, that was actually decided or classified. Based on that, actually the results will be obtained. So multi-objective differential evolution and CNN models for COVID-19 diagnosis, which is actually using chest X-ray, chest CT, as well as CT, chest CT. The other one is X-ray images. Okay, the automatic and descriptive learning rate and progressive image resizing was performed better than the COVID-net in diagnosing COVID-19. So we have actually COVID MT-net, which was actually applying improved inceptions. This is a model, inception model, to detect and localize the regions of interest from the X-ray images and chest X-ray. So it will be this particular model will be finding out and suppose take an example, lungs X-ray. So it will be just detecting the regions where actually the white, or you can say that where the regions of interest means where actually the symptoms of COVID-19 is actually found. So we have actually also the predicting, we have different AI-based classifiers, which was helpful for RT-PCR results of the COVID-19 cases. And the blood profile, that is the complete profile will be just got from the patients, and 16 simple parameters derived from that particular profile, which was helpful in finding the COVID-19 cases. The next one is deep learning techniques used for COVID-19 detection, exclusively using CT scan images. So these are some of the models. This one actually it is existing models. Okay, and also it's actually one of the very important one. Because of that, the mortality rate was very high, because COVID-19 cases were actually the infection level the lungs infection level was very, very high. They couldn't able to differentiate whether it is actually a normal pneumonia and COVID pneumonia. So that because the medication will be completely different for COVID pneumonia cases, and that medicine, I forgot the name. Remdesivir, that was actually helpful because the remdesivir is the medicine which was actually helpful for another type of respiratory syndrome virus. Sorry, another type of lung infections. It was helpful, but during this pandemic, still it is used. Uh, this remdesivir is only it was actually helpful for um, the COVID pneumonia patients, but for normal pneumonia, it is not required. So at that, because that classification in the earlier stages, it was not correctly classified, but later stages, the medical practitioners, we were one of the victims of that because my husband, he himself was actually in later October 2020, he was having actually the symptoms were not actually it was not positive, it was negative for him, but when we hospitalized he was very, very sick, and later we could able to find that the results were concluded as it he is not having COVID-19, but the chest x-ray, they could say that they could able to say that only it is pneumonia. They could not able to differentiate that whether it is actually, and there was no word called COVID pneumonia also at that time. But we got the treatment appropriately in Jipmar Hospital, and we luckily we just came out from that situation. And after 2021 only, I can say that even in December, I think they could able to tell that there is another case, COVID pneumonia, it is there. So appropriately after that, they could able to treat the patients. So this is actually, these are the different data sets, COVID-19 data sets, like 350 and 397, 350 positive cases, 397 negative cases, which were applied to DenseNet, and accuracy obtained and F1 score obtained, that actually calibrated. 350 positive cases and 465 negative cases are applied to multiple task learning models. And the other models like AlexNet, VGGNet, GoogleNet, ResNet 50, that was other pre-trained models where actually this particular CT scan images were applied. And the UNet model, the VGGNet actually, which is based on DNN, that was also considered. That model was also considered, and UNet model was also considered. So the next one is other models are ResNet 50 with the that is 2D attributes in CNN, and then the other one is 3D multiple instance learning model, and AHNet, DenseNet 201, and CNN models. And ResNet 18, that's another model. That various positive and negative cases of COVID-19 data sets, that is image data sets, CT image data sets, were applied and the results were obtained. So this is actually the literature work which actually have, which was one of my scholars working toward working in this particular area. The data set, it is actually all these things are just consolidated by herself. Her name is Suganya. So these are some of the major references. Okay. And the very important thing is because even nowadays we have actually, we can just do testing at home, RT-PCR test we can do at home. And some cases at the next level, we are going to hospital and we are just doing the testing. And next one, that is X-ray images were considered. Okay, at the next level, CT images were considered. Okay, but this is actually nowadays we have actually very sophisticated healthcare systems. With the support of that, we could able to detect. But it's actually it's a community spread. This community spread, it has to be we still have to find lots and lots of learning models as well as prediction systems to detect that is COVID-19, or you can say that SARS virus. Today it is COVID-19. Tomorrow we'll be having another version of the same virus, but we are not sure. But this viral diseases, it will be having its own impact. Presently, it is actually we have lots and lots of scope for various applications which needs to be uh, where we need to apply the models, and so that we'll get effective solutions. So these are different models applied for only for exclusively for that is actually CT images, and for that is COVID-19 detection. That's all from my side. To have actually thought of, I forgot to add conclusion slide. So I just told the conclusion. That's all the summary of the thing. So my discussion on this particular topic, especially COVID-19, I hope it will be it might be helpful for you in continuing that is further research on this area. Again, this particular models, whatever I am just telling here, definitely that can be applied for other medical applications also. Okay, so maybe today we have this particular problem. So maybe for other problems also, we can take the same models and we can apply that. Hope it will be helpful for every one of you. Any queries?
Thank you, madam.
Yeah.
Dear participant, if you have any query, please ask to madam. So unmute your mic, then ask to madam. If you have any queries, please ask to madam. Madam, I think no query, madam.
Okay, sir.
Yeah, thank you very much, madam, for your valuable speech.
Yeah, thank you so much, sir. Thank you.
For your tight schedule today.
Yes,
You are,
I had meetings with the,
yes, madam. Thank you for supporting to me, madam.
Yeah,
Thank you
I
very much,
thank
madam.
coordinators, also my my student, my scholar, Anand, for giving this opportunity. And just also this thanking the management as well as the department for facilitating this particular forum. Thank you, participant, and all the best to all. All the best, coordinators.
Thank you, Rich, madam.
Thank you so much.
Thank you, madam. Dear participant, now let's post the feedback link. 1 minute, I will post the feedback form. Then fill the feedback form and I leave from there. So. I posted this section feedback form. Please fill all the participant